Statistics 1. Finding mode of grouped data, cumulative frequency of less than type and more than type, finding median of grouped data. Mode of grouped data. We know that for ungrouped data, mode is that value among the observations which occurs most often, or we can simply say mode is the value of the observation having the maximum frequency. This data showing us wickets taken by a bowler in 10 cricket matches. If we make a frequency table, we can easily access that 2 is a number occurs maximum times. Therefore, 2 is number of wickets taken in maximum matches, that is, in 3 matches. Now this table showing us grouped data of family and number of members in a family. Now it is not possible to determine the mode by looking at the frequencies. Here we can only locate a class with the maximum frequency called the model class. The mode is a value inside the model class and is given by the formula where L equals to lower limit of the model class, H equals to size of the class interval, assuming all class sizes to be equal.
F1 is equal to frequency of the model class. F0 is equal to frequency of the class preceding the model class. F2 is equal to frequency of the class succeeding the model class.
Here the maximum frequency of the class is 8 and the class corresponding to this frequency is 3 to 5. So the model class is 3 to 5. Let us take a formula to find the mode of data. In model class 3 to 5, lower limit L of model class equals to 3. Class size H equals to 2.
F1 is equal to
frequency of the model class equals to 8. Frequency
F0
of class preceding the model class equals to 7. Frequency F2 of class succeeding the model class equals to 2. Now let us substitute these values in the formula. We get 3.286, the mode of given data. Merits of mode. It should be simple to understand, easy to calculate. It should be capable of further mathematical treatment. It is not affected by extreme value. It can either be determined graphically or by inspection. Demerit of mode. It should be based on all the observations. It is not capable of further mathematical treatment. It is neither unique nor exit. It cannot be determined in case of grouped frequency distribution if model class is at the end of the distribution. median of a grouped data. Median is a measure of central tendency, which gives the value of the middlemost observation in the data. Suppose we have to find the median of the following data, which gives the marks out of 50 obtained by 100 students in a test. In class 9, for finding the median of ungrouped data, we first arrange the data values of the observation in ascending order. Let us arrange marks obtained by students in ascending order. Now we can see that number of students becomes frequency for data of marks obtained. Now we know if number of observations is odd, the median is the nth plus 1 by 2 observation, and if number of observations is even, then the median will be the average of the nth plus 2 and the nth by 2 plus 1 observations. Here n equals to 100, that is, n is even. Therefore, median will be average of 50th and 51st observation. Now, let us find 50th and 51st observation in the given data. Now consider marks obtained by students as upper limit and count total number of students up to that upper limit. That is, total number of students who got 20 marks are 6. Total number of students who got up to 25 marks are 26. Total number of students who got up to 28 marks are 50, and so on. Now, this last column of frequency table is known as cumulative frequency column, and therefore table is known as cumulative frequency table. Cumulative frequency is the sum of frequency of that class and the frequencies of its preceding class. From the table, we can see that 50th student got 28 marks, and hence we can say that 50th observation is 28 and 51 student got 29 marks. Hence, 51st observation is 29. Therefore, median of the given observation is 28 plus 29 divided by 2, and we get median equals to 28.5. The median marks 28.5 conveys the information that about 50% students obtained marks less than 28.5 and another 50% students obtained marks more than 28.5. Now let us observe this table showing grouped frequency distribution of marks obtained out of 100 by 53 students in a certain examination. Now let us try to answer some sort of questions regarding data shown. How many students have scored marks less than 10? The answer is clearly 5. How many students have scored less than 20 marks? Then we have to add number of students got 0 to 10 marks and number of students got 10 to 20 marks. In this way, we get a table which is called as cumulative frequency distribution of the less than type, and 10, 20, 30 to 100 are the upper limits of the respective class intervals. We can similarly make the table for the number of students with scores more than or equal to 0, more than or equal to 10, more than or equal to 20, and so on. To find the median of grouped data, we can use any one of these cumulative frequency distributions. The result of these two tables is the table shown. Now, in a grouped data, we may not be able to find the middle observation by looking at the cumulative frequencies, as the middle observation will be some value in a class interval. It is therefore necessary to find the values inside a class that divides the whole distribution into two halves. But which class should this be? Let us find. To find this class, we need cumulative frequencies of all the classes. Now find n by 2. We have n equals to 53. Therefore, n by 2 will be 53 by 2 equals to 26.5. Now we need to locate the class whose cumulative frequency is greater than and nearest to 26.5. 60 to 70 is the class whose cumulative frequency 29 is greater than and nearest to 26.5. Therefore, 60 to 70 is called the median class. After finding the median class, we use the following formula for calculating the median. Median equals to L plus in bracket n by 2 minus CF upon F into H, where L equals to lower limit of median class, n equals to number of observations, CF equals to cumulative frequency of class preceding the median class, F equals to frequency of median class, H equals to class size. But substituting values of all in the formula, we get median equals to 66.4. So, about half the students have scored marks less than 66.4 and the other half have scored marks more 66.4. Demerit and merits of median. Merits. It is simple to understand, easy to calculate. In some cases, it can be determined by observations. It is not affected by extreme values. It can be determined graphically. Demerit. It is not based on all the observations. It is not capable of further mathematical treatment. Its calculation requires arrangement of observation in ascending or descending order of magnitude. Interrelation between measures of central tendency. There is an empirical relationship between the three measures of central tendency. Mean minus mode equals to 3 into bracket mean minus median bracket complete. Summary. The mode for grouped data can be found by using the formula mode equals to L plus F1 minus F0 upon 2 F1 minus F0 minus F2 multiplied by H. The cumulative frequency of a class is the frequency obtained by adding the frequencies of all the classes preceding the given class. The median for grouped data is formed by using the formula median equals to L plus n by 2 minus CF upon F multiplied by H. Merits and demerits of mode. Merits and demerits of median. That is all in this lesson. Maths is fun. Keep learning.